Capturing network traffic from Chromium-based browsers like Edge and Chrome is very simple. To do so, simply open the browser and navigate to about:net-export. You're presented with a simple UI with a big Start button at the top, and in many cases, simply pushing that button alone is all you need to do. This UI does give you some other options, though. In particular, the most important option is around the sensitivity of the data that you're capturing. By default, the browser will attempt to strip private information, things like credentials using HTTP authentication, and cookies. When in stripped mode, cookies and other sensitive data will be replaced by a note that the data was removed. So for instance, you'll see 33 bytes of cookie data removed instead of the raw cookie string. This means that captures from the browser are less likely to leak critical information, and thus they're a bit safer to include in bug reports and transfer around. However, there still is the possibility of sensitive data in captures, so you do need to handle these captures carefully and use secure mechanisms when communicating, particularly with clients where you don't know what kind of data they may have inadvertently included in their capture. For some types of bug repros, particularly issues related to cookies or login, it is relatively important to choose the Include Cookies and Credentials option so that that data will be available for diagnosis. When you do that, obviously great care needs to be taken to ensure that the capture is properly protected, not posted in places where the data may be collected and misused by someone else. The most sensitive option is the Include Raw Bytes option. In this option, you are including the bytes of the HTTP responses from the servers, and obviously, there's a significant potential for leak of customer information. In this mode, the captures are also much larger because all of the response body bytes are present. Nevertheless, this mode is, in some respects, the most useful because it does have all of the data of the transaction. And as we'll see in a later part of this, that data can be useful, particularly if we're attempting to replay a scenario locally. But in this case, let's just get started. We'll click Start Logging to Disk, and we're prompted for a file name. Let's do simple example. Hit Enter. The browser now indicates that it's saving network events to disk. The important thing to note here is that you need to reproduce your network problem using a different tab. As soon as you navigate this tab anywhere else, your network capture will stop. So if we want to capture example.com, we open a new tab, type example.com, and hit Enter. We can navigate around, and in the background, the network capture is proceeding. When we're done, we can go back to the Network Log Export tab and click Stop Logging. There's now a button that says Show File, which will show us the file where it was stored on disk. This file can then be opened in a debugging tool, or it can be sent to someone for diagnostic purposes. The logging format for NetLog is JSON. It is very compressible, so you can put a NetLog file inside a zip file and usually save more than half of the file size at least. If you want to start a new capture, simply click Start Over and the UI will reset. Now, as noted on this page, the default way to analyze a netlog is through what's called the NetLog Viewer. The NetLog Viewer is a web application. When we click on this link, we're taken to netlogviewer.appspot.com. Let's take a look at what happens by default when we open this file. Click Choose File. Pick the file that we just downloaded, simple example.json. Now we see there's a ton of information in this file. On the left-hand side, you'll see a variety of tabs. By default, we're on the Import tab. There's some basic metadata that's exposed about when the file was created, what level of sensitivity was used. Default, as we mentioned before, tries to strip private data, but if it says there's full bytes or sensitive information is included, you'll be able to see that right here. full build information of the browser. This can be very useful if you find, for instance, that the customer who collected a capture for you was inadvertently running an old version. You can see information about the operating system, the command line that was used to launch the browser, including flags and switches that may have been created by the user's settings inside /whack flags. And then you'll also see active field trial groups. This information can be incredibly useful for determining whether or not there's potentially some sort of experiment that is causing a customer's browser to behave differently than yours. Within the Proxy tab, you can see information about whether or not this was captured from a browser that was configured to use a proxy. The Events tab is where most of the interesting data is, so we'll get to that in a moment. The Timeline tab can show information about how the requests proceeded over time. I've never actually found a use for this tab, but it's interesting to look at. The DNS tab will show details about the client's DNS configuration, as well as all of the host names that have been resolved in this instance and their caching, things like that, the addresses that were resolved. This can be useful if there was a DNS problem causing the user to see a server differently than you did. Sockets, similar to the prior one, it'll show you all of the connections to the servers that were made. Alt service mappings, I've not yet found any use for that one. HTTP2 will show the HTTP2 sessions that are underway in the capture. You can see the number of streams and unclaimed and claimed and push noticed and things like that. This one has generally not been terribly useful for me, but occasionally it's interesting if there's a case where a server was not performing HTTP2 when we thought it might be. Quick is very similar to the HTTP2, but it has additional information about the client's Quick or HTTP3 protocol implementation and what options are enabled. Reporting. Reporting is used for things like network error reporting. So if a website had asked to be notified of network errors via the reporting mechanism, you can see those reports in here. Cache provides information about the state of the client's cache. In practice, I've never found a use for this. Modules will show you a variety of information about the client's configuration. One of the cool things in it is it'll show all of the browser extensions that are loaded and whether or not they're enabled, as well as their versions. And so in some cases, someone will send us a network capture saying, hey, something didn't work quite right. And I just hop right here and say, oh, you have an ad blocker extension installed. Have you tried turning that off to reproduce the problem? And they say, oh yeah, problem went away. And so sometimes I don't even get back into the deep logging and so forth. I just look at what extensions are loaded. There's also information about low-level WinSock providers, so basically things that are plugged into the network stack. We haven't seen problems in this space very often, but back in the day when things tried to extend the overall operating system network stack, occasionally we would see problems here. Pre-render is related to the pre-render feature of the browser. Again, we don't tend to see any issues here, but it is interesting to understand whether pre-renders did happen and what information was there. Now, as mentioned previously, the Events tab is where most of the action is. The browser records events for almost everything that happens in the network layer. These events are shown with a type, as well as a description, which offers some information about what happened in that particular event. And as you can see, there are quite a lot of events. In most cases, the events of interest are the URL request events. So if we type URL request, we can filter the list down to the URL requests that were made in this session. So in this case, let's take a look at the first one. Expand the pane on the right, and we will see information about the browser's request. We see that the browser attempted to do a post request to the URL srtb.msn.com whack auction. There's an analysis of whether or not this request needs to be pre-flighted under the rules of cross-origin resource sharing. And the answer is yes. And the reason is there was a disallowed header. What that means is the request to the server attempted to send a header that is not ordinarily permitted. In this case, my guess is it's the XMSH client ID header. But in any case, the result comes back and says, yes, you're allowed to send me that header. So the request becomes alive. It is a priority medium. There's a traffic annotation, which is a number which reflects which part of the browser is making this request. So sometimes you'll see things like it is an Omnibox request, or you'll see that it's a request from the resource downloader in Blink, which is the HTML engine. You'll see various events about the processing of the job. So you see that the request starts. You'll see it has an initiator. It has a site for cookies, which indicates whether or not the site is being loaded in a third-party context. You'll see some information about cookies and whether or not they're being sent on the request. So if you've ever heard about changes like same site by default cookies, you can use the information from the cookie inclusion events to determine whether or not a cookie was being sent or not. On this case, for instance, you can see that this was same site none, included by same site strict. And then ultimately, you end up seeing the request headers of the request. And you can see the HTTP2 sending of the request. You'll notice all the headers are in lowercase because it is an HTTP2 request. And you can see the information being sent to the server. And then you can see that the response is received and the response headers are there. So this provides a tremendous level of detail, including things like how the stream, the HTTP stream's window size expands and contracts. But you're not limited to just the URL request information. You'll see information about how the socket itself was being used. You'll see things about how the certificate verification process during the HTTPS handshake went on. You can see the raw certificates themselves in base64 encoded form. They can be saved to disk, or you can use various tools to interpret them and see the information about the certificate. You'll also see DNS events, assuming you're not behind a proxy. You'll see information about the sharing of connections, so as a connection is reused. And one of the very cool things is because this is in the network stack, and unlike Fiddler, you can see cache lookups. So you can see whether or not a response was loaded out of the local cache and didn't even hit the network. This is not a capability that Fiddler has. Fiddler, as a proxy, only sees requests that hit the network. Having said that, many of our support folks, and myself as well, have found that Fiddler's representation of traffic is often simpler to use and faster to get started with. Fortunately, Fiddler is extensible, and I added a plugin for Fiddler that allows you to import netlogs. So let's take a quick look at that. Start Fiddler. We'll start it in viewer mode because we don't actually need to see any live network traffic. We'll clear the web sessions list. We'll choose File, Import Sessions. Now, I've installed the Fiddler netlog importer. So from the file type list, I pick netlog.json. I choose Next. I'm going to go pick the file that I just created. That's simple example. Now what's happening is Fiddler parses this log and attempts to recreate a Fiddler-style view of the network traffic as loaded out of the logs. Now, by default, Chromium's netlog is not including response bodies. And so if we pick one of these requests, what we'll see is, double-click on it to inspect it, we'll see that Fiddler notes that the response body information is not available. Now, it incorrectly claims that it was dropped to conserve memory, but the general idea is right, that the information is just not available. And what this allows us to do is very quickly go through the netlog and see an easy-to-use representation. So for instance, if we were only having a problem with, say, Bing.com, for instance, we can just alt-click to select all of the Bing.com sessions, Shift-Delete to delete everything that's not a Bing.com session, and now we can just look directly at the information for Bing.com requests. Now, sometimes we'll find that we actually need to go back to the netlog to correlate some information we had, some information that Fiddler's not exposing. For instance, if we wanted to better understand the DNS lookup time, or whether a DNS lookup occurred or hit the cache. To do this, right-click on the session in Fiddler and choose Properties. Within Properties, one of the things that you'll see is that there's a xnetlog URL request ID, and that URL request is 2048. We'll also see some other parsing. So I mentioned traffic annotation earlier. So in this case, this URL request had a traffic annotation of 101.845.102. And Fiddler helpfully tells you that's the Blink resource loader that actually caused that request. But let's take that 2098 value, and we'll go back to our netlog view. Do ID 2098, and we see this URL request. And so this is going to show us all of the lower level information, some of which was not included in Fiddler. Fiddler, for instance, does not necessarily know how the private access network check proceeded, whether or not this resource was deemed to be on the user's intranet or not. You'll see information about the cookie inclusion status for each cookie. If a cookie was excluded, Fiddler will warn you in the UI, but it won't provide quite as much information as the netlog itself did. So Fiddler is an extremely powerful way to quickly analyze the information in a netlog. And if you're familiar with using Fiddler, the netlog importer can save you a whole bunch of time. But sometimes we just analyze the netlog directly. As mentioned, there are some benefits of doing things this way, rather than just using Fiddler to capture directly. For one thing, customers don't need to install anything external to capture with the netlog format. They just navigate to the URL, click Start, perform their repro, click Stop, and they've got a JSON file that can be shared with you. You don't need to have them worry about configuring certificates or doing other complicated procedures. Additionally, you don't have as much of an observer effect. So an observer effect is when the browser behaves differently because you're looking at it. And Fiddler, unfortunately, because it is a proxy, entails a number of observer effects. For one thing, when you're using Fiddler, you're using a proxy. The browser will behave differently when a proxy is in the path. Fiddler also is not a perfect proxy. There's things that it cannot presently work with. So the default Windows Fiddler Classic version does not proxy HTTP2. HTTP2 and HTTP3 are downgraded to HTTP 1.1. Well, with NetLog, you don't have that problem. The NetLog capture means that Chromium is using HTTP2 to servers normally, and the NetLog will reflect that. Finally, because the NetLog captures are by default sanitized a bit, you have a lower worry about inadvertently capturing sensitive information because cookie headers and so forth are stripped by default. So, in many cases, NetLog is a better choice than Fiddler's SAS format. There are, however, a few limitations for netlogs. One of them is that netlogs have presently no way to capture post request bodies, which means that even if you choose the include raw bytes option, the netlog will not include the post data, so web forms or other submissions using the post method. That data will not be in the capture. So if your scenario entails debugging something with a post request, you'll probably want to use something like Fiddler. One of the alternative tools that you can use is the F12 developer tools. The F12 developer tools within the browser have the ability to export data in HTTP archive format, HAR. So for that format, if we go to example.com and hit F12 to open the developer tools, we can choose network. We can choose to preserve the log, perform a navigation, go back to the dev tools. You'll see the information is here. You have the ability to select those sessions, to right-click, and to choose Save All as HAR with content. Simple example.har. The HTTP archive format has the ability to gather some information that is not available in Fiddler, and some of the information that is not available in netlog format. The important thing is that HAR does include post request bodies. And so if you don't have Fiddler available, it is one approach for capturing that information. Unfortunately, the dev tools get a somewhat biased view of the network traffic in the browser. and it's possible for the dev tools to, we'll call it fib. They may show information that is not quite right. It's in line with the intent of what the browser was doing, but the actual transaction may have proceeded differently. In terms of analyzing a HAR file, there's not a whole ton of choices. There are some public debuggers, but this is another place where Fiddler has the ability to help you out. So file, import, by default, HTTP archive is a format that's included, no plugin necessary. So if we choose HTTP archive format, click next, and choose simple example.har, we'll see that those network requests were captured. And you can view those network requests. And you can see that, for instance, the response bodies are included. You can decode those response bodies. In this case, it's actually a bit of a lie. The server tells you in the HTTP archive format that it was content encoded with Brotli, but the data that's included in the HAR format has already been decoded. And so you do get some weird effects like that. But the DevTools format is sometimes useful. In most cases, however, the way that I think about this is that I will try to get a netlog first. And if the netlog doesn't work because the customer needs to look at post data or similar, then I'll try just using Fiddler. But if using Fiddler is not appropriate, then I'll use the F12 developer tools. One of the very cool things that you can do if you have a capture either in HAR format or in netlog format with raw bytes is you can use Fiddler to replay that capture. So you can collect your web sessions and you can go over to Fiddler's autoresponder tab, and then you can play back data that was captured from the customer environment. So even if you don't have the ability to do some repro that's on their corporate network or similar, you can actually use the capture to replay data back through Fiddler. And so you potentially could reproduce the problem locally. This is very useful for debugging higher level issues around, for instance, page layout and so forth. For low level networking issues, Fiddler's playback is not going to exactly mimic what happened in the network on the customer's machine. So it's not as useful for those kinds of things. But overall, traffic capture is one of the most powerful tools that you have available to you. And within Chromium-based browsers like Microsoft Edge, you have many options for getting that data.